So I think it should be okay to start by now, if that's okay with you, ma'am.
Yeah, yeah, sure. I'll just share my presentation.
Okay, sure. Uh, Hi everyone, welcome to today's guest lecture for week 6. Thank you all for joining us, and we are pleased to have Dr. Madhumita with us today. She is an ornithologist who did her PhD from the Salim Ali Center for Ornithology and Natural History. She's worked with as a scientist as well at BNHS, and she's worked with various projects related to bird migration, Central Asian Flyway National Action Plan, and wetland management projects. So we're very pleased to have you here, and we well, all yours.
Thank you, Nafisa. I'm not able to share my screen. It's saying that host disabled.
Oh,
Yeah, given.
okay.
Are you able to see my screen now?
It is, yeah, now it's available. I mean, it's visible.
It's okay now?
Yeah, it's visible now.
So, coming about bird migration, it's around one of the most interesting topic in avian biology, not only in avian biology but in animal world itself. Uh, so, coming to what is migration, actually is a to and fro movement of a bird. For in this case, we are talking only about birds. So, a to and fro movement from any one place to another, from place A to B, or from several places. It's a large scale, probably mostly talk migration in perspectives of very large scale migration. For example, most of our talks will be related to a very long distance migration, the birds coming from Arctic towards India. A migration typically is for longer duration, but we will come to know that there are different kinds of migration, which is for shorter duration also. It's mostly depend upon favorable to unfavorable conditions. It's mostly unfavorable conditions in which the bird is not able to survive in that particular environment for a particular span of time, and hence choosing to go away from that area towards another suitable area. Mostly these migration patterns are predictable. There are certain patterns which are not predictable, but most of the migration, what we know now, is are mostly predictable migration. We mostly know the routes of the birds until and unless they decide to take some other route. Uh, the migration can be of individual or of population. So it's not necessary that the whole population of a species will be migrating. There could be a fraction of that same species or population which may not choose to migrate. It may depend upon a particular race or maybe distribution of around the geographical area where they breed. Mostly migration are non-stop. No, mostly migrations have a lot of stopovers, but in avian world, it is known to have very extreme set of migration, which pertains to the non-stop migration for the birds. As we proceed, we will talk more about it. Migration is mostly an innate behavior. It is inborn in most of the individuals for mostly for long distance migrants, and an innate behavior, and it's not taught. But some of the migratory birds, we see that once the juveniles are ready to fly, they follow the adults. They don't choose their own path, but they follow the adults. So it depends upon different species of birds.
Ma'am, sorry to interrupt you, but there's a lot of background noise.
What a background. Maybe I'll switch off my fan just a minute. Is it better a little bit now?
Yeah,
Okay.
it's better.
Okay. So sorry about that.
No, no, no.
So migration is something known for a very longer period of time. We have examples in the pre-Vedic period where it is mentioned in Vishnu Purana that geese are returning towards the Himalayas, and there are a lot of other examples also in which these particular mentions, particularly of geese, are mentioned by different writers. Uh, so these are some of the examples which you can see in the screen. Mostly, what you will find is about this geese which are coming, and we are assuming those geese which they are talking are bar-headed goose rather than the grey-lag goose. Some of the literature of 13th century also mentions about the changing seasons, the bird, how with changing season the bird community is also changing. We are not able to. So myths and beliefs. Aristotle is known to known is a very known naturalist as well as a philosopher. Uh, though he also assumed some of the most the large myths which is around migration is mostly given by Aristotle. Though he also noted a lot of true migration examples also. So the migration of doves and cranes according to the season was something noted by him and written in around 350 BC. He assumed because for a very valid reason, he assumed that there are some birds which get transformed. So red starts annually transform themselves to into robins in the winter. So we are talking somewhere near to Greece, and this is what happens when the red starts have their annual migration, the robins will come in. So then naturally it was assumed that these are the same birds, but they are just having a different morph or a different color on their feathers. So they assumed something like this. But otherwise, this migration phenomena was quite noted. And if we go a little bit deeper in our local knowledge also, there are many instances where the cropping pattern is determined by what birds are coming in. Many northeastern states are also having that kind of a belief that once they see this particular bird, and that is the harvest season. And you can see throughout most of the tribal areas as well that these kind of folklores are alive, which makes quite a lot of sense. Um so why do birds migrate? What you can see now is mostly this is an example. This map is an example of the area where there are no snow in the Arctic region. Arctic regions, whatever you're seeing above India towards the end of the map, is what we will call an Arctic region. So these regions we are not seeing any snow right now. But once there are this change of season is there, you can see this all are snow covered areas. You can see even in Himalayas also, there are certain parts which are covered by snow throughout the year. It's not like this is the occurrence, but mostly this is kind of the face of the earth during that time. So when there is ice developing, or when there is a temperature lower down, these birds prefer to come down towards south, towards the equator, because of the warmer climate and the abundance of food, which will deteriorate in those areas of breeding. So this is the migration pattern we mostly talk about, which is very easy to relate to, and which, of course, it's very a direct understanding that since there is an ice over there, there is no food resources, so birds choose to migrate. But there are some, it's not like all the birds migrate. There are some birds who are adapted to these kind of extreme temperature also, and you can see them throughout of the year. That is a different kind of adaptation. What we are talking would be the adaptation by birds for extreme migration. So what does it, why do they do it? So mostly because to maximize resource use. Why? For example, in the season, let's say in the September onward season, the temperature starts going down in the Arctic regions or Palearctic regions, and then these birds start to getting they will not be able to fetch for themselves that much food and all. So then they start migrating towards the south to get more resources. So actually, and then when they go back in the summer season in those regions in the higher latitudes, so they have abundance of food, more sunlight. So you know that near to Arctic areas you will have maximum sunlight, probably like there will not be a darkness even for an hour in some cases. So they have a lot of sunlight there, and hence a lot of abundance of food and the resources maximizing. So by migrating, they are actually optimizing their resource use. They are actually using both ways. They are using maximum resources. They are also having best nesting location. Now these the birds which do nest in the high latitude region, these are not much dominated by humans. These are not very easy places, also suitable places. These are very secure locations for them to do the nesting, and not only secure locations in that way, but also because of the abundance of food which they can provide to their fledglings while they're there. Of course, they escape the harsh winters, they avoid predators, they reduce competition. If they stay there with these large populations which are in the Arctic regions, they will compete for the food. So by coming out of that area, they actually reduce their competition so that they can use more of the resources. There are a lot of theories that why they migrate such a long distances. One of the which we clear indication we saw is the ice which is developing, or the extreme temperature which is there in the polar regions. Another theory which have been under consideration for a very long time, and it do have proof, is also if you remember in your geography lessons about Pangea and Laurasia. So when it was all joined together at the end of probably 150 million years ago. So during that time, the bird species where it's assumed that the bird species had certain distribution. Once the plates started moving, the continents started moving apart. This behavior, of course, this happened in a very long time span. So they started evolving this behavior to coming back to the region where they breed. So this is how they developed this is like the migration, the long distance migration behavior got evolved. One of the theory which makes a lot of sense also. Uh, before you understand the migration, we also need to understand what is the the zoogeographical regions we are talking about. So let's talk only about India or Indian subcontinent perspectives. Most of the birds which we receive will are from the palearctic regions of the continent. We also receive birds from Sahara Arabian subregions. We also receive some birds from Afrotropical regions. Uh, we also receive birds from some Sino-Himalayan subregion. So you can see the whatever surrounding area from in India we are receiving. You also can see that India is sort of coming at the end of it. After that we have the sea and we have small islands, of course. All you can see that India could be supporting a large population of many of the migratory birds which would be choosing to come towards India from the Palearctic regions. Of course, from the Palearctic region, there are birds who are going to Africa and other European countries also. So this is how we talk about, in Indian perspectives, the birds which we receive from different regions. Uh, how this initiation happens of migration? Consider yourself, you are in this somewhere around Russia. You see a sudden change, not sudden, but a elaborate change in the day length. The birds have this photoreceptors in brain which get triggers saying that it's the time to start initiating your migration. So you need to work towards it. You need to prepare towards it. So this in turn triggers some hormonal changes. What are these hormonal changes? Will be gain in weight. They will be voraciously feeding on a very energy efficient food. They will increase their fat storage. Fat is stored in the form of lipids. This is a very good source of energy for the birds to travel for very long distances. Once they start feeding in a large, they will start. So mostly the body weight will, while they migrate, will be 50 to 60% of their original body mass. So they are quite heavy. You can say in terms that they are quite obese when they start actually migrating. The gain in weight also depends on what kind of migration you are doing. Is this migration a non-stop migration, which will be very difficult, or it is having number of stops, so you can just stop somewhere to again refuel your energy storage and then commence your journey again. Molting of new feathers, so there will be new. So birds needs very strong feathers naturally to have these kind of migrations. The development of specifically primary feathers are taken into account apart from other body feathers because that is how they will go through this extreme flight. So molting of feathers also requires a lot of energy investment. So there is in a bird's life history, breeding uh, and molting feathers and migration could be three very energy intensive traits in their life. Molting of feathers also require a lot of energy. Hence, it will be a long drawn process to prepare yourself for a longer duration of migration. Once all these are met, then they commence the journey. The journey depends upon what kind of bird it is. There are certain birds which choose to fly alone or in a very small flock, or there are birds who choose to fly in a very large flock, or there are birds which will go in batches. So a first batch will leave, and the second batch will leave, and the third batch, and hence they will meet in whatever stopover regions, or they will meet in the wintering region. So how do birds migrate typically? The birds use a combination of navigation equipments the same way we go through. Of course, you will not blindly follow a Google Earth, a Google Map, what we do, and you have seen that you sometime you go into other direction or may take a wrong turn. So you also depend upon a lot of other cues if you are going to a place. Like this, the bird also use sun compass, star compass, odor magnetic compass. So, what is a sun compass? Is in this case, the bird we are when we are saying about sun compass, the bird is mostly which is choosing to fly during the daytime. So, which are the birds which will fly during the daytime? Are the eagles, the heavier birds, the vultures, so or the harriers. These birds fly. These birds are first of all quite heavy, and these birds also choose to fly in thermals. This is also a way of going through difficult migration journey. For example, let's say uh, a black eagle, no, sorry, a black-shouldered kite or something, in which, let's say it's coming from Mongolia or somewhere. So they will choose to fly on the thermals which is generated in the daytime so that they can soar higher. More higher they will go, the temperature will cool down a bit, which makes them easier for them to fly so that they dissipate that energy which is coming through their burning of fat is dissipated. So their body temperature also come in control and they are more efficient in their flying. The star compass are mostly for the birds who choose to fly at night or migrate at night. These birds can be like flycatchers, certain warblers, and some goose, some cranes, which choose to fly at night. So, but it's not necessary the bird which may fly at night will always fly at night, or it will not choose to fly in the morning time. It depends upon what kind of geographical barriers the bird is crossing. If certain barriers can be crossed at night, it will be safer for them to cross. If some barriers need to be crossed at morning, so it will be crossed in the morning. So some birds who choose to, for example, the birds who may, for example, let's say a flycatcher which is crossing a desert region may choose to fly in the night hours because so that it can avoid the predators. The predators will be these eagles, these hawks, which will be choosing to migrate in the daytime. So what they do is they migrate during the night time. They migrate quite a height, and then they come down towards any stopover site. Of course, to their knowing, they will stop for the daytime, rest there, feed as much as possible, rest probably for 1 or 2 days or probably for few hours, and then take again flight the next night to reach the area, their wintering area. There are odor map. The bird in certain cases can smell, and it forms an odor map around it so that every region it passes through it have particular odor. For that odor also, of course, the birds needs to fly a little bit down than its usual height. Magnetic map, we now know it's quite, we have seen in the pigeons, especially the homing instinct, and they have this kind of inbuilt instinct in which they know which place to go. uh, for in case of migratory birds, it is not only migratory birds. In most of the birds there is a the small content of iron which is in the inner ear, which sort of helps them to navigate through the Earth's magnetic field. So these are combinations of navigation tools which they use. Mm, so how do they? What makes them special from the regular birds is that most of the birds, especially if you see the long distance birds or the shore birds, you will see they have pointed wings. So the photo which you can see is of clover. It's a sand clover, lesser sand clover. So here you also can see the feathers are quite new. These are very new feathers. So these are quite pointed. If you see, for example, feathers of babblers, uh, let's say common babbler, those kind of birds, you will see it's more rounded. But these are very pointed wings. These pointed wings helps them to work through the winds when they are flying. So it give them an aerodynamic advantage over other birds. They also choose to travel in V formations. How this is to reduce the drag. The bird which is in the front will be taking most of the impact of the headwinds which are coming towards and dissipating it, the force, so that the rest of the birds which are behind will be able to fly much efficiently. The position of the bird changes. It's not like only single bird is doing the formation is headed by the single bird, because it's a quite energy intensive also. So the birds switch this place, and it's sort of again an aerodynamic understanding where the whole flock can fly very easily. Uh, they also store energy in the form of dense lipids. So in the photo, you can see the first bird is not having any fat storage as such. It's this part. This is near to the belly region, and in the second photo you can see a yellow formation. That's the fat. Uh, we can see these fat deposition mostly in land birds. It's very easy to see, but in mostly in the shorebirds, it's quite difficult to see this kind of fat deposition until unless you are not weighing them physically, that how much weight they're actually in. So these, what they do is they start feeding. So you can see that the second photo is quite a heavy fat storage in a way. So what it happens is if the bird choose, so the birds when migrating have to store little bit higher then mostly it is required for the journey. Why? Because at times it is not known that whether the bird will be able to stop in a place for refuel or some extreme cases may happen. In these cases, there are birds which choose to, have little bit higher amount of fat than usual. But anyway, they do carry 50 to 60% of their body mass. They store in form of lipids because it's the most energy efficient form of uh, uh, any fuel which can fuel them towards their migration. Uh, in some cases, for example, bar-tailed godwit, it has been seen that atrophy of non-essential organs. So there are some organs which will not be essential for them. So in case of extreme migration, for example, this particular bird, which have been which covered around 11,000 kilometers in span of 9 days. So and this there was no stoppage for this particular bird as such. It was a non-stop flight from Alaska towards New Zealand. So these kind of like for example, bar-tailed godwit will be having this atrophy of non-essential organs. So certain organs will sort of reduce in weight. They will start expending energy from that kind of organ. So you can see there will be an expansion and then the compression of certain kind of organs. This is seen in very extreme kind of migration. High efficiency for muscle control and contraction. So again, a very bar-headed goose, which is known to the highest flying over the Himalayas and all. So these kind of birds also have like the muscles in a way are made. Their body is in a way with a hollow bone, and the hemoglobin in their blood is able to function in a way that it is 10% less oxygen which is in the flying altitude. They will be able to fly through it. These are strong birds. For example, bar-headed goose itself can fly towards the headwing. We'll come to know more about headwings later. But the headwings is something which comes to front of you. So when the wind is coming in front of you, it's very difficult to fly. But it's seen that while bar-headed goose fly or fly over the Himalayas, they do encounter headwinds, and these are very strong birds. They can go through. They actually take advantage of headwinds to maintain their navigational accuracy towards their destination. Their hemoglobin is also made in a way, or the hemoglobin have evolved not only in this bird but in most of the migratory birds, that they, because they fly in a very high altitude, so they can function in a lower oxygen also. And now coming to the patterns of migration, we talk about north-south migration, which we have already seen. The latitudinal migration coming from Russia towards India will be a north-south migration. Then there is a west-east, which is longitudinal migration, altitudinal, and there are other which is seen here, a lot of other kinds of migration. But of course, migration is a very complex phenomena to understand. But if you want to simplify it in a way, so there you just can simplify in case of long distance or short distance migration. So from long distance, short distance migration, then we can see a lot of patterns which the bird follow. Coming to the patterns, we have already spoke about this bar-tailed godwit. The pattern of migration of continuous flight depends upon different species, where they are coming from and where they are going. So the distance matters to influence the way you migrate. The barriers In case of India, Himalaya is a very interesting geographical barrier for us, and it really the migratory birds which we receive in India. It's very interesting to see that how they use Himalayan passes to come over India, or they choose not to take this Himalayan passes and took probably a longer route so that they can avoid this Himalayan range and then come towards India. There are birds who choose both of it. It's not like only heavy or big birds choose to fly through the Himalayan passes. There are birds, there are small birds also, some like essentals and other warbler species who choose to take this kind of passes. How do we know that they are taking these kind of passes? Before this advanced technology of satellite studies. We know because there are mountaineers who used to access these passes to climb to the mountains, and there have been bodies of birds, that birds which have been found, or a mountaineer have heard during night time that this bird is passing, or they have seen. So this is how we came to know quite like a long time before itself that birds are using Himalayas are a barrier, though for many of the species they are able to circumvent this barrier and come along. Uh, the pattern is also influenced what kind of wind is there. We will and further we will come to know that some of the why a particular bird will choose not to follow the same migration path, the path which it may choose to take here towards India, but it will go toward to another part towards its breeding. So this depends upon what kind of wind is available for them. Of course, these birds are flying. Wind makes a lot of difference for them, so it depends. They are having a tailwind. Some of the birds which choose to fly in particular months will wait for this tailwind to happen. Tailwind is something behind you, behind the tail of the bird. So it will help you to push up. The bird will be able to, with minimum energy, it will be able to rise towards higher altitude so that it can fly easy. The crosswind is something which is across the wings. Just imagine your wings are open and the wind which is coming towards the wings are the crosswinds. So these crosswinds are quite difficult to manage. Headwinds, again, I told the one which come towards in front of you, and soaring, which is because of the thermals which hawks are using, hawks or eagles are using. So it depends again what kind of wind is available for them. So sometimes even if the wind is, it may be due to any weather conditions, the wind is not available, they may not choose to migrate in that particular part, or once they started migrating and something happened, they will choose to have a stopover somewhere so that the conditions improve. Again, when I spoke about the weather, the bird's decision to fly, of course, depends upon a lot about weather conditions. It depends upon mostly many times about the local weather condition of the area. If the birds are trying to fly back to the breeding regions, so now we know that because there are a lot of cyclonic uh, 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 cyclones, tropical cyclones, which are now quite regular to see. So in these cases, the bird may little bit wait for the weather to calm down, or it may choose to go to an area where it can avoid this kind of weather. So this kind of wind understanding of wind pattern is what the bird understands to choose when to migrate. But it's not always if the decision will be correct. Sometimes, of course, the decision won't be correct. Again, the migration pattern also will depend upon how whether they want to refuel or whether they don't want to refuel. If they want to refuel, they will choose a migration path which will have a lot of refueling sites. If not, they will. If there is no refueling site, for example, the first photo which you see of distance, this particular bird doesn't have a luxury of a stopover site because it's crossing the sea, an open sea, and it cannot. It's a bird which cannot sort of float on the sea for resting, or take cover somewhere in a floating device or something. So it's a bird which will not be able to do that.
Ma'am, your presentation is not, we can't see your presentation.
Okay. I will just stop sharing and then again I'll share it.
Yeah.
You're able to see now?
Yeah, yeah.
Okay. Thank you. Mm. So the most typical pattern of migration is north-south. We have been speaking about it since the start of it. So in this particular case, a Wimbledon, you would see, let me, if it is possible. Is arrow is visible?
Yes.
Okay. So in this case, a bird which have been a whimbrel which was tagged somewhere near to Singapore, you can see the northward migration and the southward migration of this bird. So this also this is just a typical example of north-south migration. In this, you can see the bird which chose for a northward migration, and you can see it is actually crossing through Himalayas. It's crossing through the northeastern part of the Himalayas. Of course, it's using certain passes. It's taking a stopover somewhere near to China. There's this Kyungin region of China which is taking rest to, and then it is going ahead towards its breeding site, which is this particular area. And so you can see the bird which is breeding in mostly in the little bit western side of the Russia is choosing to go through the Himalayas. This is actually easier for the bird because it's able to cover a little bit lesser distance and probably a favorable wind pattern which is okay for the bird to fly rather than taking a diversion towards a place where it can avoid Himalayas. Also, there are birds which are nesting in the eastern part of the Russia, this particular map in the Russian region. You can see that they are, of course, choosing a different route, again coming back to Singapore for as their wintering site. Now you can see how many stopovers they have seen. So in northward migration, probably the bird took quite very less stopovers. So just two stopovers when the bird was migrating northward, while the bird while coming towards again back to Singapore, it again took many stopovers while coming. That this can be of due to various reasons. Of course, we are not able to know what will be the weight of the bird during this kind of migration. This is particularly a satellite tracking study. So we don't know what happened exactly with the weight of the bird or whether it was able to refuel, but probably something to do with the stopover ecology and how it is able to track it. Uh, Again, west-east is a very common pattern of migration we see. One of the example is common cuckoo. So this particular bird was tagged in southern Korea, and then you can see then again lot of stopovers it is taking from, and it's flying past India to go towards Africa. This particular cuckoo is also, of course, taking advantage of certain kind of insects which are flying through the same path so that it can keep afloat. This is another example of west east. We have example like Amur falcons also, which do this west to east and east to west. So this is mostly a different way of migration. Again, a common migration pattern. Altitudinal migration is now when we the all the migration so far we have been talking have been a long distance migration. This is an example of short distance migration. So this particular study was carried out on Sataya Trogapan and Bhutan. So they have tagged a lot of birds, and then they saw a movement of bird which is happening in those Himalayan regions. So this bird hardly migrated or rather walked merely 13 kilometers down slope or up slope. It depends on the particular bird which they have tagged. So for certain birds, they saw that these birds were moving down. For certain bird, they saw that in winter, while the snow, while snowfall happened, the bird started climbing up. So it somewhat reverse our understanding that altitudinal migration only will be from up to down. That when the snow is there, the bird will come down because they want to avoid snow. But in this case, it was not. It was comfortable in that area. So this particular species, it was seen that it is not moving. The movement is not that higher, but it's more probably in the non-breeding season. There are certain birds which are choosing to go around, use the mic. If you see these kind of, if you can see in the green marks in the map, you can see that these birds sort of, they are using the passes in the valleys to go towards their particular non-breeding site. So these are sort of exploring. It again depends upon the seasonal condition which is there. There are certain birds, for example, blue-capped rock thrush, those kind of birds who choose to migrate when there is, for example, let's say. The birds which are there in the Himalayas, even Himalayan bulbul. If it is in the higher altitude, if there is a sudden change, if there is a sudden snowfall, it may choose to come down, but it will be a very small distance covered. It may choose to go back once things are fine. So these are very short distance, but very interesting. It's something which is not studied much. Altitudinal migration, we are finding a lot yet. uh, a loop migration. So when I was talking about, the bird may choose another path to go back to their breeding site. So in this map, you can see the breeding site somewhere in Mongolia and the wintering site somewhere in Gujarat and Rajasthan. So the bird is coming towards India. It's crossing, you can see it's crossing Nepal, it's crossing over Himalayas and then coming to Rajasthan. But while going back, it is taking another way. It's going to from Pakistan, Afghanistan, Uzbekistan, Kyrgyzstan, and then towards Mongolia. It is taking a longer route. So when it came towards India, it took like 4896 kilometers, 29 to 72 days. But while going back, it took 6034 kilometers, 35 to 66 days. So why it is probably what the researchers have studied is, this is probably because the availability of resources that way while they go back, and the wind which is available for them to go back. So these are called loop migrations. Uh, why these migration patterns are important to understand? In this case, you can see that if you would like to, if there is a threat to this particular bird, it is their democile crane, and you want to conserve these birds, so you need to understand all the migration paths. So if you are able to preserve only one stretch of migration path and not the other one, still your conservation effort will be almost nil, because anyway you will not be able to save them while they go back. So you see there is a long trajectory of area which is covered while these birds are migrating, and hence your conservation perspectives have also to be need to be scaled up. uh, Leapfrog migration, it's something again which was considered very usual earlier, but now because of the advanced technology, we are understanding more that not all birds are doing this, or there are certain birds which, for example, a particular starling which was known to migrate from North to South America using this kind of leapfrog migration, are now known that it is not doing that. It was an understanding which was developed after they have put satellite transmitters. So, but this bird, Bulwer's petrel, is known to migrate in this form. So what is happening in leapfrog migration is very simple. So a population which is breeding in the north part will migrate further towards south, while the population which is breeding towards, let me so the bird, for example, this is the northern population which is breeding. It have to come down to the southern wintering area, because the this particular breeding area from the, let's say, population A and B. So the population A is towards the northern breeding area and population B is towards the southern breeding area. So the southern breeding area will cover a very less distance to come towards down to towards the northern breeding area. So the population have to jump. The population which is in the northern latitude may have to jump this southern population and come further down to south. This is called leapfrog migration, or sort of a jump migration, because they want to avoid competition with this particular population, and hence they choose to migrate. So the population which is further away on the latitude will have to fly higher. Sorry, will have to fly longer. So one of the example is this particular pelagic bird which use this strategy of migration. There are other pattern of migration is also known as nomadic migration. It's also known as irregular migration. It's depend upon the availability of food and resources. So if nomadic migration, it just happen in case there are this most of this migration which we will see now is mostly dependent upon the food availability. So if the food is not available in that particular time, so it will be it will just it mostly it will not migrate, but circumstances will be so, then they will choose to migrate, and hence a nomadic migration. Eruptive migration, it's a rare phenomena. It doesn't happen usually until unless there is something drastic happened in their area. For example, let's say we are in Mumbai and there are certain places which they drastically they just cut forest, and there are certain birds which we are not able to feed. So this whole group of birds will go in search of some other part where they can feed. So you may feel that it's a migration, but it's an eruptive year because some disturbance have happened and the bird choose to migrate. It's not about cutting of trees or maybe something drastic like particular insect or food which they are dependent on is not available. Seasonal, again, we can see that seasonal migration we have already spoke about. This seasonal, of course, migration depends winter and summer. Those migrations also seasonal also depend upon the food availability. For example, some of the birds, local birds, may choose to migrate in a very short distance. For example, in morning they are just migrating to 50 kilometers ahead to find some particular food which they know they are having, and then evening they are just returning back to the particular area. Or for some seasonal migration, they are prolonging their stay on a particular resource availability and then coming back. Uh, Drift, again, mostly seen in pelagic bird. When the weather conditions are extreme, they drift from their original course and they may land in somewhere else. So many pelagic birds which you see in our Indian coast, apart from being a visitor, sometime most of the times they are sort of, because of some extreme weather condition, they have flown out towards the sea and they landed here. Another interesting concept is the mold migration. This is development of new feathers post breeding. It is only seen in geese and certain songbirds. In India, in India or associated India, we are yet to see these kind of migrations in a very clear picture. But if you, for example, Canada goose, these are examples which actually go towards a particular place in which they shed off their feathers. And in that particular time, they are quite immobile, like they are flightless, sort of flightless, very much prone to the predator, high pressure on hunting on them, and so they choose to go to this area so that they can just have their new feathers so that they can migrate further. This molt migration can happen in many stages. They can, for example, some birds which are choosing to fly to the wintering area will have stopover site. That particular stopover site may also act as a molting site, so they will develop maybe 2 or 3 fresh feathers, and then again they will fly so that they come to another stopover site. Or they may come to the wintering area and just refresh their whole feathers. The migration study techniques, coming to migration study techniques. I have, how much time I have? Okay, 2 minutes. Direct observations are the basic observation which we do for bird migration. So these are what these direct observations are. Direct observation. Direct observations are mostly like these bird counts which recently happened 16 to 19. So when these kind of these kind of bird census which happens, they give information about what kind of birds are available, of course, in this region, so that you can correlate in a larger data set that if there is. So for example, you see there is a certain, if you are a birder, you see at winter months there is a certain spike in particular area. This because there is a migration population which is coming, filtering in, and hence increasing your more sighting of different species, or higher number of birds. There are census, there are targeted surveys which researchers carried out, like these kind of things are there. Uh, and of course, there is very interesting. Again, there is an interesting technique of direct observation is moon watching, which now have been sort of reductant. Now it's not done as such. So what happens in this particular moon watching is, if you see this image, so what you have to do is particularly take your telescope and point it out towards the face of the moon. And when the particular bird is flying, if you are able to identify mostly the genus of the bird, then you are noting, and there will be like 1 to 2 hours or 3 hours of observation, and then you have to note down that what bird is passing through, or if you are just count the number of birds which are passing through. This is mostly applicable in those areas, and still people are doing this. It's an interesting way of watching migratory birds. They are doing this in areas where there is a, how to say, let's say Gulf of Mexico, where there is a corridor, a migratory corridor. It's a very small strait of area where the birds are migrating towards Africa. So there in the sorry towards the southern America. So so these are the stretches in which you will see the bird in particular time. So people are still there who are observing in parts of Wisconsin, like from Canada down towards North America, like when the birds is funneling through this area. So these are some of the areas. In India, of course, we also have these kind of areas. Probably it's just near to the passes, but of course it's a very difficult task to go to these areas and do these kind of observations. This observations is nothing new. This observation have been first carried out by a researcher when the researcher, particular researcher ornithologist, went to a astronomical museum, and then when it was going through the telescope, it of course saw some birds flying, and this phenomena then adapted later on. This whole process of moon watching got redundant once the radar studies came into picture. During the World War II, when this radar technology was more advanced in a way, during that time, while of course these radars were used to see whether the what aircrafts are passing through, so the enemy aircrafts, to see how far or which are the aircrafts which are passing. So during while they were studying this data, they saw some other glitches which they called angels during that time. This is mostly, we are talking about part of England where they were monitoring with radars, Britain, and also they thought that these are the some of the images they were not able to say that these are not enemy vessels, or they are not enemy aircrafts, but what else it is. So then they sort of understood that these are organisms, or these are like flying objects which are migrating. These flying objects could be insects, they could be birds, that they didn't knew. Of course, now we have technology. Radar technology is so advanced that we are able to sort of this data. We are able to filter out that whether these are the birds which are migrating, or whether these are insects which are migrating. So what is the advantage of radar technology is, like, we are able to see a larger flock, and we are able to predict the movement of the birds. So this kind of technology is for, to understand the larger movement of birds which is happening. The same way, like we use eBird to understand the larger movement which is happening, we depend upon observation by individuals. In these cases, it is mostly, very sort of clear cut data of huge flocks which are passing through, which an individual of course cannot do, because we cannot see the birds flying out at night. And you will be amazed to know that how many birds choose to fly at night with very huge numbers. So this is the advantage of radar technology. Of course, there are disadvantages, because sometimes you will not be able to know that which bird is flying, or what species it is. This after this, so these are some of the technology which was developed quite. Bird ringing also a technology. It's not technology, but a way of understanding which was developed quite a long back. When there are like this Otburn, the ornithologist who tied silver strings to the birds to understand whether the bird is coming back. So, like this, many ornithologists or many naturalists who have tied something, a unique thing in their in the bird's feet, to understand whether it's the same bird or not. So, bird ringing and color marking are some of those examples, that how we. So these are very basic examples of understanding, one way of understanding migration. Bird ringing and color marking are there. There are many other this kind of particular technique can be used to understand many aspects of bird life history. For this particular, we are using it for understanding the migration pattern. So bird rings are some unique steel rings which are made up of ink alloy, metal, these kind of alloys. So they will have unique size, a unique number which will be fitted to them. So this is placed in, as per the species, it is placed on the tibia or the tarsus, and it have unique identification code. Every country who may be doing this particular work of bird ringing will be having their individual code. So once if you see a bird, for example, from India, there will be particular address to make sure that this particular bird belongs to this particular organization, and hence you can contact them if you find the bird. Color marking, you can see there are a lot of ways to color mark of these birds. Some of which we are already using in India in very large manner to understand what is happening and where the bird is going. So the advantage of all these two methods, it's quite inexpensive in ways. Of course, it involves a lot of people to do it because you have to capture birds in large numbers and everything. But then, of course, it's an easy way. So once the bird, just for example, marked color bird is seen somewhere in China, the bird watcher may inform to this particular agency that they have seen, and it's a straight line connection which we will join. Of course, we don't know how it reached. It's just a straight line connection which we will make. Then there are satellite transmitters. Again, coming back to the same example which we have moved to, these can calculate exact locations. These are often real-time data. They can be attached surgically or implanted or externally. So in this bird, you can see it have been externally attached in the back form of it's sort of a backpack they will have, or otherwise they can just attach it with they'll shave off little bit of feather and they can attach it as a glue, and then later the bird will just that it will drop once it develops further. So these for some like long distance for the birds, for the studies which they don't want to do much of a migration for long years, they may choose to this kind of. So depending upon what kind of migration study you want to take up, you will have these kind of instruments. So these instruments mostly depends upon the instruments here which I have shown mostly depend. It's there is lot more devices in this, especially tracking devices. There are many kind of tracking devices. It depends what do you want as a researcher. What do you want to concentrate? Do you want to find a stopover site? Do you want to know that whether the bird is using this particular passage, or do you just want to know whether the bird is able to fly through this particular barrier or not? So that depend upon what exactly your question is. Um, Coming back to the satellite tracking, this satellite tracking is a quite costly method because, of course, it is using satellites. There are across satellite. There is a particular satellite which, of course, US is having that in which it's particularly used for migratory birds. The transmitters are so small now that it could be fitted to many smaller birds. Mostly satellite transmitters are bigger in size, so it cannot be used for small birds, but now, of course, we are developing in a very fast pace. You don't have to retrieve this particular instrument from the bird. It may drop, it may lose the backpack, the string which is attached to the backpack may loosen up and the instrument may fall. But the data will be available to you till the functionality is there. Sometimes the transmitter may also work even after falling. So there are cases even in India where we have gone and collected particular satellite this instrument because it's still functioning and can be used for some other bird. But it's of course it's a high cost. GPS, GSM tags. There are many kinds of tags. I'm just giving you a very sort of a very narrow examples. There are many other kinds of instruments. So these are these GSM GPS tags. Of course, they have a GPS instrument on it, and which helps them to gather the GPS, the exact locations. And there is a card. There is a SIM card. So the in this, of course, again, you don't have to retrieve this instrument from this bird, but you are able to get your SMS. So you have to sort of set the instrument in a way that when do you want this information to come to you. So in this, recapture is not required, but SMS is required. So in this particular case, you will see this migrating eagles. So they of course, this particular researchers, this group of researchers, they have put on this kind of tags, and they chose to migrate away, and away from their usual paths. Of course, that time we didn't knew that how far these birds will migrate, and because they were so high in roaming, so because they are getting SMS, so they had lot of data charges. So this also something to look out for, that how your particular study is funded so that you are able to put these kind of instruments. So this particular researcher group, of course, faced a lot of issues in which they had to find ways how to settle this huge amount, which because the bird just chose to fly away from the towers, and the roaming charges, like if we go to, for example, Bangladesh, Nepal nearby area, you will rack up your, or you just chose to go to Turkmenistan or other areas, you'll rack up more roaming charges. The same way this bird started racking up. Another very interesting study technique is light level geolocators. So you can see these are in the map. The map, you can see this only gives particular and then a larger area that what is happening. It depends upon the daylight. This particular instrument is based on the principle that every part of the earth, every single part of the earth will have different daylight. So when this instrument is able to calculate the longitude, latitude of the place depending upon the amount of sunlight which the bird is receiving. Hence, if this particular instrument may not work very well in tropical regions, because of course we have more sunlight, direct sunlight, which is coming to the instrument. But if you are able to put this particular instrument on a bird which choose to fly, for example, Arctic tern, which is flying one pole to another pole, this will give excellent results. This particular geo level light level geolocator, because it is able to grasp the different light levels in a very broader spectrum. So more broader the spectrum, the accuracy will increase. These are very small and very cost effective. So, but it needs to be recaptured. So it's mostly carried out in places where the birds breed. You have to capture them from the nest. You can place it like that in the backpack, or if the bird is a little bit bigger, you can place it on the leg via help of a flag, and let the bird free. And then again, when the bird is coming back again to the breeding area, you have to put a lot of effort again to capture. So what happens is, for example, if you are putting these kind of instrument on 10 birds, so you probably will be able to capture one or four, not more than that. Out of 10 to 10 may not be possible to capture. So that way there are certain birds you will never be able to recapture. So that is a different setback for this kind of instrument. But of course, this have given us very good result in coming years, that how the bird is migrating. Then there is Motus tags. It is yet to come in India. Actually, it is yet to come in Asia, but it's largely used in US and other countries, in which a lot of receiver stations are required. So in this photo, you can see a monarch butterfly. So this particular instrument is very very small. It's very lightweight. So it's so lightweight that it can be put on a monarch butterfly. Just imagine that, a gram of butterfly. So this instrument is of course a nanotechnology. What is a drawback in this is you need lot of receiver stations. The blue dots which you are seeing in the map are the receiver stations. So when the bird is passing through, if it is having, like for example, it is having like 2 or 3 receiver stations, so the triangulation method of calculating distance will happen, in which the accuracy of the bird which is passing through will increase. So it may not give you the exact locations, but of course, if you have more receiving towers, let's say maybe 50 kilometers apart or lesser than that, you will have more accuracy in calculating. These have a lot of advantages of because it's all, again, low cost, but again you have to invest on the uh, the antenna, and where to put it, and it will be safe or not. So these kind of expenditure will rack up. This again, but this technology is very very developing, and it's something interesting to see how it is coming through. So coming through all this, what we have studied, what we have gone through now, this what you see is a global flyway. If you recollect the maps which we have seen earlier, most of the paths which we were seeing is birds in perspectives to India were coming through this portion of Central Asian flyway. So India falls under Central Asian flyway. This particular flyway is made based on the shorebird migration. So shorebird migration, which I have shown with lot of ringing and flags in earlier presentation. Shorebirds like curlew sandpiper, bar-tailed godwit, whimbrels, these kind of birds which are there for like waders. So a large scale study in all these places have happened, and on ducks as well as shorebirds. And this particular flyway was crafted out on those bases. But if you go towards land birds, of course, this particularly will not fall, because land birds we are receiving many birds from Europe as well, Africa as well. There are certain waders which we are receiving from Africa. So now you can see that India is part of Central Asian Flyway. It is also part of East Asian Australasian Flyway. It's also part of West Asian East African Flyway. So why these flyways are important? First of all this flyway concept came on our findings that where actually this particular region these birds are coming from, and again to collaborate with other countries in terms of conservation and how to manage these migratory birds, and to have a dialogue between different countries. So Central Asian flyway are in which India is also part of. We are sort of the largest, and we are doing a lot of conservation activities as per Indian government to towards this migratory flyway. So now this migratory flyway we have like 30 countries. India is one of them. In that way, different flyways have so many countries. So it's just the way for policy or conservation efforts to go into on a basis of scientific understanding. So this was mostly how just a little bit exposure how is a bird migration done, and with all this how we are solving, so not even solving but able to conserve in ways, or able to understand that how bird is migrating through. This is a developing science, of course, more like many, unlike many of the phenomena, this the understanding as we progress with more and more studies is developing. So the information which we have received, which you have gone through now, probably will be changing as we grow more in understanding. So something really interesting to look into. But of course, bird migration is not something for which you will require like a lot of big instruments and lot of collaborations cross country to understand. It is something which you can understand through direct observations also. So if you want to observe bird migration, now this is the February. If you stay near somewhere near to any coastal part or near to a wetland, it's a good time to go and see what is happening, because probably depending on which part of India you are, uh, these birds will be starting to develop a breeding plumage, which is very very nice to see. And if you are very new to shorebird identification, now is the time where you can actually invest and go and see to identify. So the bird will be developing very nice breeding plumage, in which it will be very easy for you to identify which particular bird is, and probably depending upon what place you are, they will be leaving this particular region, or basically the Deccan part of India, maybe before April. For some species, it may be beyond, but before April, so that they can migrate back to the areas. So if you are interested, just visit some of the areas. Even if you are going to any forested area, of course there will be different kind of forest birds to see, but again you will be able to see lot of mold which is happening in these kind of birds. Thank you.
Thank you so much for your talk, ma'am. This is a very interesting topic. If you all have any questions, you can type them in. There is one question from Gaurav. I can read it out. Is there an open global database dedicated only to tagged birds and migration for people to study their behavior? Are there websites for monarch butterflies?
Yes, there are databases. There's something called movement bank. So you can just Google this move bank in which they have this. These are sort of open data sources in which researchers have given their tracking data to understand. For monarch butterfly in particular, I need to search whether it is, but I'm sure there is some paper which is there.
Uh, Someone said, I didn't understand the isotope topic. What did you mean by that?
So I didn't cover the isotope topic in this. There was one of the, but I didn't cover it. So isotope is isotope. It's a way in which you collect feathers. Particular, for example, a bird which have been coming through, let's say, Uzbekistan, will have certain kind of elements in the feathers which will sort of which act as markers to those particular regions. So when the bird is coming down to India, when you are collecting these feathers, of course you will have a lot of analysis which is done. I am not from that field, but researchers are able to track the migration path because of these kind of identifiers. These identifiers can be deposits of soil. These identifiers can be some deposits of some kind of uh, elements which is there on the feathers. So this is mostly isotope, like stable isotope studies which was carried out. A complex and many, of course, very high at cost. Not that much done in case of India, but of course they are now developing it also. Nafisa, you are on mute. Uh, okay, Nafisa, you are on mute, so I will just read the
Yeah, yeah,
question.
yeah.
Okay. Will the returning bird develop the breeding plumage in wintering ground? Will the returning bird develop breeding plumage in the wintering ground and stopover sites, or finally when they reach to the breeding ground? What about breeding behavior? Do they engage in breeding behavior in midways too? Okay. The bird mostly would have developed the breeding plumage while it is on the wintering ground. Many of the birds, for example, what I have seen when I was working in Gujarat, in the month of mostly in the month of March, like February onwards, you will be able to see the development of the breeding plumage. By March, you will be able to see that many of the birds have developed complete breeding plumage. The weight will be quite good also in that way, when because we used to measure the bird. So the way is also good. So we would assume that these birds are almost ready to fly. But there are birds which we have seen which were there till April, and they chose to fly around. By the second week of April. So by that time, they were what we can see through photographs is that they have completely developed their breeding plumage. Some of the birds may choose to complete their breeding plumage in the stopover sites. But while when they reach breeding site, it is assumed, or it's mostly the cases, they don't want to waste any time to develop again breeding plumage while they because the time span for them to breed is quite small and the competition is high. So because they have developed this breeding plumage again, mostly males will develop this breeding plumage, or in cases of birds like farlopes, where the female will develop breeding plumage, depends who is doing the nesting duty. So in those cases, the birds will completely develop the breeding plumage before it comes to the wintering area, so that it can get it can mark a territory, attract the female. In some cases, the pairing may happen while on the stopover sites also, or the pairing may happen after they go to the breeding site. The pairing will happen, and they will just as soon as possible they will complete their breeding cycle, because there is another factor, because the egg can be predated. In case the egg is predated, the egg or the nesting is destroyed, so the bird is having time to go for the second clutch or the third clutch. So that way it will always complete. Mostly it will complete. Do they engage in breeding behavior in midway too? So far, I'm not sure. Whatever I have studied so far, they don't engage in breeding behavior in midways. I have not seen any midway actually. Whatever I've seen is wintering area. So I'm not sure. This is some question which probably I will answer later.
There's one is loop migration, same as elliptical migration. The other lecture on migration spoke of elliptical migration.
What is the question?
Uh, 1 second. There's one saying is loop migration the same as elliptical migration?
The lecture language model. Yeah, it's almost same. It's same elliptical migration. So what this simple just go by the word. If it is a loop migration, so this loop migration is also figure of eight migration. So it will just have a figure of eight. So these are different words, meaning are almost same.
Thank you. There's another that says from Naveen. There are some migratory birds that stay in India and not return back to their breeding ground, such as wood sandpiper. I'm not sure if that was
So
yeah.
So what happens is sometimes when we see this, we say that the birds are overwintering. So this phenomena of overwintering is mostly probably for the first year birds. So the bird which is born, let's say the first migration, it commenced the migration somewhere in August, or sorry, June or July. It commenced the migration from parts of Russia coming towards India. It's the first migration for that bird. So in those cases it may not choose to go back. Many of the birds which we see overwintering could be the first year birds, they are not ready to breed yet, and there are certain birds who choose to stay back in the wintering grounds, who probably will not be able to fly off because they have not gained particular weight which is needed for them, so they choose to stay back and they choose not to breed. So we say India not returning by the breeding now. So yes, there are some birds which do not choose to return back to the wintering area, and it doesn't happen. See, for example, some of the bird which could be a first year bird or a second year bird which may not choose to migrate but may choose to explore also. So it may not go for a wintering particular area, but it may again go some other region to explore, but may not stay back, just exploring the other areas. Or for example, one of the bird which I have tagged in Gujarat, we have seen that it missed like for 1 year it stayed throughout the year, it stayed in the same area. That was the first year bird. So yeah, there are some birds which stay back.
Migrating behavior can be seen. Can migrating behavior be observed in birds who are born in like captivity?
Yeah, yes, it's an innate behavior. So most of the there are lab studies which have been carried out on buntings and migratory birds which have this kind of migratory behavior. It is seen that they will have there will be a phase. It's there is a German word for it, but there is a phase in which they will be very restless. That's a migration phase, and they will be going like, for example, if they are in a cage, so they will just fly from one direction to other in particular time. If their time of migration is night, so if you are able to sort of if you are able to darken the cage, so they will understand according to their biological clock that this is dark, this is time to migrate. And you can see the migration restlessness in this lab setting will be so that they will also start feeding up. It is something innate, so their body is saying to do that. The same way, for example, if your finger is getting pricked, you are feeling the pain, you are moving away because you know that is this, it's something involuntary which happens with them. So yes, they do show that.
That's very interesting. Uh, there's one more from that says the do birds migrate during the monsoon season to India?
Yes, you can see the example of Jacobine's cuckoo, which choose, and it is also called chatak. In Sanskrit literature, we can see that it have lot of mention that chatak is a hairbringer of monsoon. So wherever it flies, the monsoon will follow up. So these kind of birds do migrate on the onset of monsoon. Again, it depends upon the resource which is there. There are certain resources which will be made available from them during monsoon. So by despite cuckoo or Jacobin's cuckoo is a very good example of the migration which happens during the monsoon time.
Uh, the same person asked about like regarding with reference to the same question regarding black baza.
Does the same thing happen when birds get back buzzer? I'm not able to see. What? Where, sorry, can you
Uh,
repeat the question?
yeah, the same person asked a question. He said, "Can you explain if you could explain about the migration about black baza?"
I am not sure. I've yet to come or do any study on black buzzer. So probably again I'll get back to this question. I'm not sure.
So, Gaurav Soman said, "Does the same thing happen when birds get old, probably unfit for travel and breeding?" He said, with reference to what you mentioned about first year birds overwintering.
Yes, there will be certain bird who may be not fit to migrate, but of course we cannot relate to the age. Why? Because for a bird, if you are not tagging them from the birth, if it is having a unique identification code, then only we will be able to sort of see that we can say that okay, this bird is so many years old and it is not able to do any this kind of activity. So it's very difficult to say in case of birds. For some of the pelagic birds which live longer and it have been sort of ring, they did do this migration for quite a lot of good years for them, and they successfully completed that breeding cycle way long years. I cannot say how many exact years. I know that this particular bird was 72 years, but I don't know how many times it did breed. But age is a factor which we are not able to correlate much because we don't know much about that.
So, is there any bird that comes to India when there's winter in southern hemisphere, Australia?
I don't think so, but there is one of the bird, Oriental Prattern Cole, which was seen to come towards India during I don't know what season it was. It was 2 years back. This was the first time discovery which happened that this Oriental Prattern Cole have come somewhere to Karnataka. I think it bred, and then there was, and then it went back. It's again an example. It came from another way and went back to another way. There are certain birds which do, but I don't know whether it is winters in southern hemisphere in Australia. Australia again, in which part of Australia? Because Australia itself is an example of wintering ground for the pelagic for the Arctic birds which are coming. So which part of Australia you're talking about is again depend. Mostly Australia is closer to equator, of course. So naturally it's again near to a tropic region, and it is not having that kind of migration, of course.
I don't seem to see any other questions, but I think if there are any other questions, I think they can post it in the forum as well. But this has been a very interesting talk. Thank you so much.
Thank you.
I I I come from Meghalaya, so like we've had a lot of cases of armor falcons, for instance, and then Himalayan griffon vultures as well in like the Jantia Hills here. So there have been concerns over, for instance, like when the Himalayan griffon vultures were here, some people were feeding them. So there were concerns raised over, for instance, the fact that they would overstay in that particular region. So I wanted to ask you about that as well.
That whether they will overstay if the
Yeah,
resource is
yeah, yeah.
available. I don't think they will overstay. Yeah, in a sense. See, for example, I can give you another example. Is this democile cranes which come towards Rajasthan and Khichen? It was not originally sort of in that huge numbers. Birds don't used to come. The people started provisioning more, and now few hundreds, and now there are sort of thousands and lakhs of birds which were coming. But of course, they are going back for breeding. So
So
griffon vulture in this particular case, griffin vultures, if it is Meghalaya, it is anyway very close to the breeding areas of griffin vulture.
Yeah.
It, even if it chose to stay back for a time, or if the conducive environment is there for any local movement of breeding, it may stay on May. But provisioning do make a difference on bird choosing. So probably if the griffin vultures start receiving this particular food every year, then they probably will be a regular visitor
Yeah,
whenever on
because
their journey.
it became like a whole spectacle thing where, like, all the villagers started feeding them a lot of meat and all that. So it was
Yeah,
very
interesting.
interesting to look at. Thank you so much for this
Thank you.
wonderful lecture, and for, all of this was very interesting to listen to. And thank you so much for your time, and thank you so much to all the participants as well. Regarding the live session videos that haven't been available, I will post whatever's there on the discussion forum and inform NPTEL as well. So thank you so much for this, and thank you to everyone.
Thank you.